Alright, here let's talk about the factor theorem and look at a few examples. A polynomial f of x has a factor of x minus k if and only if f of k is equal to 0. Alright, so what this says is that if you have a factor of x minus k, just like that, then if you put k into the function, you get 0. So for example, let's just use the easy one. F of x equals x minus k. If I put k into this function, I get k minus k, which is 0. So f of k is 0, right? So what it says is that if k is 0, meaning if k, when you put it in there, produces a 0, then x minus k is a factor. If x minus k is a factor, then k, when you put it in there, gives you 0. It goes both ways. Of course, it's a little harder to see with those letters, so let's check an example. All right, x squared minus x minus 6. We can factor this function. I think it's x minus 3 and x plus 2, right? Multiply to get negative 6, add to negative 1, okay? And then those are my factors. That's factored. But what are the zeros? What makes it equal to 0? Well, x equal to 3 does, and x equal to negative 2 does. So what we're saying is, at f of 3, I get 0 out. If I put a 3 in there, 3 squared is 9, minus 3 is 6, 6 minus 6 is 0. Put a negative 2 in there. Negative 2 squared is 4, plus 2 minus 6 is 0 as well. So at 3 we get 0, and at negative 2 we get 0. So then we can write the factors. X minus 3 is a factor, and x plus 2 is a factor. So it goes both ways again. If 3 is a 0, then x minus 3 is a factor. If x minus 3 is a factor, if I put 3 in there, I get 0. Both ways. Let's look at a couple more examples. Here we go. Factor this guy. What two numbers multiply to 4, but add up to 4? X plus 2 and x plus 2. Right. Alright, what are the zeros? Negative 2, negative 2. Okay, it's repeated this time, so we consider it to be 1, 0, but now we say we have something else. We call multiplicity. Excuse me, if you've watched the movie Multiplicity with Michael Keaton, remember he makes copies of himself. It's kind of an older one, so maybe you haven't seen it, who knows. But basically it's how many copies of the negative 2 are there? There are 2 copies. So what we say is that the 0 is negative 2 with multiplicity 2. Alright, next example, one right below it here. State the zeros and the multiplicity of the examples. Alright, well this is factored for us. What's the 0 of the first one? 3. What's the 0 of the second one? 1. That's what makes them 0, right? But of the first one, it has a multiplicity of 3 right there. The second one, what's the multiplicity? Well, it's whatever power's up here. There's only 1, so it's multiplicity 1. We don't really need to write it. So we can just say multiplicity of 1 if we want. But we don't have to write multiplicity 1 out. So 3, multiplicity 3, 1, multiplicity 1. And so that means there are 1, 2, 3, 4 zeros to this, right? There are 4 zeros. If you multiply that out, if you multiply this out here, you're going to get x to the 4th. Because this is x cubed if you multiply it out times another x, so there are 4 zeros. Alright, over here, x cubed, what's the 0 for that one? If it's just an x outside like that, that means 0 is a 0. 0 times anything. The 0 for this one, negative 1 makes that 0, right? And the 0 for this one, it's a little tougher. If you can't tell, set it equal to 0. See, I could have set all those equal to 0 and solved, and then solve. I'm adding 1 there. 2x equals 1. Dividing by 2. So x equals 1/2. My other 0 is a half. Now what's my multiplicities? Multiplicity of 0 would be 3. Multiplicity of negative 1 is 1. And multiplicity of 1/2 is 1. So there we go. In our last example, we want to take this function and write it in factored form. They tell us the zeros, so I just write them as factors. X minus 3/2 and x minus 2, right? If I put these numbers in here, I have zeros. And now I just have to work with the leading coefficient because when I multiply it out, it has to have a 13 in front. So they gave me this function, they gave me the zeros, and if I multiply this out now, I get this function back.